You can see that in their units, right? Then you can see that what now? Pressure is defined as what? It's defined as what? Force over what? Area. So you see what now? Force over area. Force is Newton and what now? Meter squared. All those are what now? Their units. I'll explain this in a bit. In the next what now class, I'll explain all of this, right? Now let's use dimensioning to explain what we just talked about, as in the whole concept of derived what now quantities. Is that okay? Under dimensioning, anywhere I have mass, I'll represent it with capital letter what? M. Anywhere I have length, I'll represent the capital letter what? L. Yeah. Remember, length stands for what? Any form of what now? Distance. Do you understand? Are you getting what I'm saying? Yeah. Whether it's radius, whether it's thickness, whether it's height, whether it's depth, whether it's perimeter, whether it's circumference, all those are classified under what now? Length. Is that okay? So then time with what? My capital letter what? C. Is that okay? Now let me remind you of something. What does mass measure? Mass measures what now? How heavy a thing is. You get what I'm saying? And the unit of mass is what? Kilogram. Do you remember that? Yeah. The unit of mass is what? I keep in that face. You listen, man. Mass measures how heavy what now? A thing is. The unit of mass is what? Kilogram. Yeah. When I talk, I'll talk about mass and all that. I'll talk about it separately. Then I will explain the equipment to use for what now, measuring them and all that. But now, then what about length? Length is measuring what now? The space between what? 2 points. The space between what now? 2 points. Is that okay? The space between 2 points what now? Is what now? Is length. Is that okay? Distance and all that. So, and we said the unit is what? Meters, right? Yeah. What about time? Time, the unit is what? Seconds. What does time measure? Time measures what now? The interval between which events occur in what? In nature. I came here in the morning, and what now? So, what did we do at that time? What are we doing now? The space between the time we came and the time we're going to leave is what now? It's time. You got what I'm trying to say? Is that okay? Yeah. Thank you. So, area we said is what now? Length times what? Length. Right? Yeah. How do I know this? What's the area of a square? Area of a square is actually length times length. Area of a rectangle is what? Length times breadth. What's the area of a any area you're looking for? You're just combining what now? Two lengths. I explained that another time. Is that right? Yeah. Now, what do we say length is? Length is what? Capital letter L, right? Yeah. So under dimension, I have capital letter L times capital letter what now? L. And if I have two L's, it's what now? L squared. Is that okay? Yeah. So if I'm having L squared, what's going to be the unit? The unit is going to be what now? Meter squared. Is that right? This is my using dimensioning now to what now? Explain this. Is that okay? Yeah. We said volume is always defined as what? Length times what? Times length times. Okay. Length times what? Length times what? Length. I already said length is what? Now capital what? L. Capital L. Capital what? L. That will what now? L raised to the power of what? 3. Is that okay? Yeah. So I know that what now? The unit becomes what now? Meter what? Meter cube. Is that alright? Yeah. So we see that what now? Area, dimensioning, I'm going to write as what? L squared. Volume in dimension, I write as what now? L cube. Unit here is what? Meter squared. Unit here is what? Meter cube. Are you with me? Yes. Now, if I'm doing something like speed, what's the definition of speed? Is distance over what? Over time. And what is distance? Distance is what? My length. So it's capital L divided by what now? T. Do you understand what I'm trying to say? Yeah. So I can have it as what? As L slash what? T. This is like division sign. Is that right? Yeah. So I have length what now? Against what now? Time. This is dimension for what? For speed. Is that right? Yeah. So I can now tell you that what? The unit will be what? What is length? Length is meters per what now? Per seconds for time. You understand what I'm trying to say? This is dimension. This is what now? Unit. Is that okay? Now remember what I told you. The basic difference between speed and velocity is that while one is just measuring what now? Magnitude. The ones are measuring magnitude and what now? Direction. For example, if I tell you that the car is moving at 20 kilometers per hour, that is what? Speed. If I tell you that the car is moving at 20 kilometers per hour due west, is now what now? Velocity. Do you understand? What makes one different from the other is that one has what now? Direction. The other one doesn't have what? Direction. Is that okay? So we have seen that what now? Speed or velocity has a dimension of what? Length over time, right? And then the unit becomes what now? Meters for length or now? Over seconds or meters per seconds. Is that right? Yes. So if I'm doing for what now? For something like acceleration. What's the definition of acceleration? Acceleration is speed
over time.
Over what now? Over time. Yeah. And what I we say speed is? Speed is what? Length over time. Right?
Yeah.
And there's another time what now at the bottom. Are you getting it? Yeah. Length over time. So eventually I'll get what now? Length over what? Time squared. Is that right? Are you getting it?
Yeah.
So the dimension here becomes what now? Length. Yeah. So what would the unit be? Unit becomes what now? Meters or now? Square. Now, if you understand dimensioning fully, I'm telling you the truth. So many topics that you're going to have issues with for calculations, you would have solved from here. I'm telling you. What I'm doing now is looking like I'm wasting time, but it's not true. This is one of the most important topics in what now? In physics. Are you getting it? If you understand all these combinations, when you start doing calculations, you will not have issues. Are you with me? Okay, let's go over acceleration again. So acceleration is what now? Speed. Sorry, velocity actually. Velocity is what they come here. Velocity over what? Over time. I want to say velocity is length over what? Over time, right? Then this time is what now? Over time again. Is that right? So I end up getting what now? Length over the time squared. So my unit becomes what now? Meters per second squared. That's simple enough, right? Whoa, see me. The definition of force. So we know that what now? We said force is what? Mass times what? Acceleration. Right? Yes. So what is mass? Mass is capital letter what? M, right? What is acceleration is what? It's L, right? L over what? T squared. You get what I'm saying?
Yeah.
So what do we say is the unit of mass? Is kilogram. What's the unit of what now? Of length? Is meter. What's the unit of time? Seconds. So I'll have what now? Kilogram, meters per what now? Per second squared. Do you get the idea? Yes. Let's do this again. We said that mass will represent as capital letter what? M, right? Yes. And then we have what now? L for what? Over the C squared. This one is what? Acceleration is L over what? C squared. Are you getting it? Yeah. So I'm combining acceleration to what now? To the mass. Do you understand? Time is what? Denominator. Length is what? Numerator. Mass is what? Numerator. So I have ml over what now? T squared. Is that okay? Mm-hmm. So eventually, this acceleration, this is what now? This is force. Are you with me? Yes. So from here now, I can write what now? The dimension of what? Of force to be what? ml slash what now? T squared. This is what dimension. So from here I can get what? The unit. Unit becomes what? Kilogram, meters, or what? Per second squared. However, because of the fact that Newton did a lot of work under force, to honor him, they used his name to replace what this. So if you are doing force in physics, you mostly see what now? Newton. You will not see kilogram, meters per what? Per second squared. But sometimes you can use kilogram, meters per what now? Second squared. But this and this they are what now? They're equivalent. Is that okay? Is that right? Yeah. So that density is what? Mass over what? Volume.
Time.
Mass over volume, please. So what is mass? Mass is capital what now? M. What is volume? Volume is what? L raised to the power of what? 3. We know that already, right? Yeah. So what we're going to have now for the dimension for density? M slash what? L raised to the power of what? 3. So what becomes the unit? Unit becomes what now? Kilogram. And what? Meter cube. The unit of mass is what? Kilogram. The unit of what now? Length is what? Meter cube. Is that right? Are we together? Yeah. Okay, let's just do this last one and then we'll wrap up the class, right? Yeah. Pressure is what? Force over what? Over area. What do we say force is? Force is what? ml over what now? T squared. ml over what? T squared. Right? Now what is area? Area is what now? L squared, right? And it's dividing, it's on the right? Yeah. So I'll take what now? L squared down, right? So I'm having L up, I'm having what now? L down. How many do I have down? 2. I have 1 up. So this 1 will cancel and then cancel remaining what now? 1 down. So eventually I'm going to get what now? M on top and what now? L at the bottom. I write L before T now. And what now? T squared. You get what I'm saying? Yeah. So the dimension for pressure becomes what now? M slash what? L T squared. Is that right? So what's going to be the unit? Mass is what? Kilogram. Length is what? Meter. Time is what? Second squared. You get what I'm saying? Yes. So this is dimension. This is what now? The unit. Right? Just like Newton did a lot of work under what now? Force, and he was honored. The same way Pascal did a lot of work under what now? Pressure. So his name is also used what now? So one of the units of what? Of pressure. You get what I'm saying? either kilogram per meter per second squared, or use what now? Pascal. Is that right? But basically, right? This will give you what now? The fundamentals for what now? For dimensioning. As we do this again, we're going to get better. All right?